Hello students, in this video we'll see an example of changing the limits of integration. Let's evaluate the integral from 0 to 1, the integral from e to the y to e to the e of 1 over x natural log of x dx dy. I want to plot this region and change limits of integration, so let's do so. Here's my y-axis, here's my x-axis. And note that x is going to go from this curve over here. So the bottom limit for x is between the curve e to the y and e to the e. So x goes up to this terminal value over here of just e to the e. So that's the terminal value for x. Y goes between 0 and 1. So there's a y value of 1. So my region's confined over here. And then what happens? I know y goes between 0 and 1. So that's my range of y between 0 and 1. And I want to figure out the range of x. So x goes between e to the e, and the bottom limit for x is e to the y. So if we isolate this equation over here and look at it, it becomes the same thing as saying if e to the y is equal to x, then e to the y is equal to the natural log of x, and y is equal to the natural log of the natural log of x. Now the natural log of the natural log of x is an increasing function, and when I plug in x equals e into this equation over here, so I want to know when y is equal to 0. So y is equal to 0 corresponds to what value of x? So y equals 0 is the same thing as saying the natural log of the natural log of x is equal to 0, which says the natural log of x by exponentiating is equal to e to the 0, which is 1, and therefore x will be equal to e. So when x is equal to e, corresponds to the y value being equal to 0, so that's going to be a value of just plain old e. And then the natural log of the natural log of x goes from 0 and it increases all the way up to here, right? So as y goes between 0 and 1, x starts over here on this curve, and it moves over to this. So this is my region of integration, is this shape over here. That's our region of integration, okay? So if we wish to change the limits of integration, I can change the limits of integration, but instead of going horizontal, I can go up vertically like so. So in other words, so x can go from e to the e, and then what will y go from? Y will go from 0 up to this curve over here. All right, so let's change limits of integration. So we change limits of integration. We now know that x is going to go from e to the e, and then y will go from 0 up to this curve. And what is this curve? This curve is y is equal to the log of x. So y is going to go from 0 to the natural log of the natural log of x. And then I'm going to have a 1 over x natural log of x. And then I'm going to have a dy dx. And now there's no y's over here in this integral, so I can basically just integrate this directly. So this is going to be the integral from e to the e of just y over x log x. Then I'm going to have a y goes from 0 up to y equals the log of x dx. And this is going to be the integral from e to the e of the natural log of x over x natural log of x dx. And now we can make just a substitution over here. What's our substitution going to be? Our substitution is going to be, let's let u be the natural log of x. Then what will du be? Then du is going to be 1 over the natural log of x times 1 over x. So that's a perfect derivative over here. And so our integral is going to turn to what with the substitution? We're going to have the integral. Well, what will happen to when x is equal to e? This is going to turn to a 0 because I'll have the log of e, which is 1, and the log of 1, which is 0. When I have e to the e, I'm going to have the natural log of e to the e, which is going to be an e. Then the natural log of e is going to be 1. So I'm going to go from 0 to 1 of what? Then this top is going to be a u. And then the x over x log x, dx over x log x is just going to be a du. So this will be a 1/2 u squared evaluated from 0 to 1, and that's just going to be a 1/2. So if I change limits of integration, I find out that the integral in question is equal to a half. Thank you very much.